Okay, so I'm going to go over this trig assignment, review assignment. So remember, this is all stuff from grade 11. It is review. You need to know how to do all of this so that we can get into the harder applications of it in grade 12. So question 1 says, sketch 241 degrees in standard position. In which quadrant does the terminal arm lie, and what is the reference angle? So of course this is 0 degrees here, 90 degrees, 180, and 270. So 240 degrees, 41 degrees is in quadrant 3, which is here. So it's going to be in quadrant 3. The reference angle is the angle from the terminal arm to the nearest spot on the x-axis. So to figure this out, I went 241, subtract 180, and I get a reference angle of 61 degrees. So this angle here is 61. That's called our reference angle. Question 2, complete the table. Determine the measure of each angle in standard position given its reference angle and the quadrant in which the terminal arm lies. So if we are in quadrant 2, this is quadrant 2 here, and we have a reference angle of 22 degrees. That means that angle there is 22. So to find the angle in standard position, which is this, that's standard position from the positive x-axis, I take 180, subtract 22, because I'm 22 degrees short of reaching that axis, and I get 158. B has a reference angle of 48 degrees in quadrant 3. So quadrant 3 is down here. This angle is 48 degrees. So here I've gone 48 degrees past 180. So I'm going to take 180 plus 48, which gives me an angle of 228 degrees. C, we're now in quadrant 4 with a reference angle of 65 degrees. So to calculate the long way around, which would be the angle in standard position, in this case I'm going to take 360 and subtract 65 because I'm 65 degrees short of reaching that 360 degrees. And I get an angle of 295. 3, determine the exact value of side AC in the diagram below. Hint, use special triangles. So a triangle here that has 45 degrees and 45 degrees. Those two sides are equal to 1. Using Pythagorean theorem then, 1 squared plus 1 squared and square root it, you get that the hypotenuse must be root 2. So to determine the exact value of side AC, we are going to use our special triangle here along with this triangle. So using this triangle, I'm going to say that the sine of 45, so I decided to use this angle of 45. You could have used the other one, and then you would have had to use the cosine ratio. So the sine of 45 is the opposite side, which is 12, over the hypotenuse, or over side AC. The sine of 45, using the special triangle, I know that sine is equal to the opposite side of 1 over the hypotenuse. So 1 over root 2 is equal to 12 over h. When I solve for h then, I get that that side AC must be 12 root 2. Okay, your question 4 I think is on the next page. This one is here. So determine the exact value of the sine, cosine, and tangent ratios for the given angles. So here we have an angle in standard position of 240. And we want to know the sine, cosine, and tangent ratio. So remember for this, we need two things. We use our reference angle here, which in this case, if we do 240 subtract 180, we're going to get a reference angle of 60 degrees. We also need to know in which quadrant our trigonometric ratios are positive and negative. So there's numerous different ways of remembering this. But basically we know that in quadrant 1, all our ratios are positive. In quadrant 2, only sine ratio is positive. In quadrant 3, only the tangent ratio is positive. And in quadrant 4, only the cosine ratio is positive. The last thing we need to answer this is our second special triangle, which is, 30 degrees up here. 30 degrees here, 60 degrees here. This has a hypotenuse of 2. The side here is 1. And then using Pythagorean theorem, you find that this must be root 3. We are going to introduce 2 new ways of remembering these values here, but if you like the special triangles, you can continue to use them. So the sine of 240, so 240 has a reference angle of 60, so I'm really going to first answer the sine of 60, and then I'm going to use the fact that it's in quadrant 3 to come up with whether it's positive or negative. So the sine of 60 is opposite over hypotenuse, so root 3 over 2. Since we are in quadrant 3 with angle 240, only tangent is positive there, so it's going to get a negative sign. The cos of 240, I use the adjacent over the hypotenuse, so it gives me 1 over 2, or 1/2. And again, we're in quadrant 3 where cosine is negative. Tan of 240, so now from my special triangle, I'm going to use opposite over adjacent, so root 3 over 1, which is simply root 3. In quadrant 3, tan is positive, so the tan of 240 is positive root 3. Question 5. The point -2, -4 lies on the terminal arm of angle theta in standard position. Determine the exact trigonometric ratios for sine, cosine, and tangent. So we're going to start by drawing in this point. -2, -4 would be somewhere here. And we always want to connect it to the x-axis. So this is the point -2, -4. Now if I want to look at this as a triangle with side lengths, I know this is 2 because my x value is -2. This side length is 4 because it was down 4. So this side here is 2 units long, this side here is 4 units long. I can now use Pythagorean theorem here to find that the hypotenuse is the square root of 20. It asks for exact values, so I'm not going to punch this in and find a decimal. I'm going to leave it as the square root of 20, or you should know how to reduce your radicals to be 2 root 5. If you don't remember how to do that, make sure you come and see me. So now I'm ready to start coming up with my angles. Sorry, my ratios. Again, I need to remember what's positive where. So we're looking for really the sine of this angle. We are in quadrant 3, so it will be negative. Now I'm using my reference angle in here, and I'm going to say opposite over hypotenuse. So 4 over 2 root 5, which simplifies to be -2 over root 5. You will also see that these get rationalized sometimes, giving you -2 root 5 over 5. Both of those would be acceptable answers. If it's multiple choice, they're likely going to give you the rationalized one. Cosine, so now I take the adjacent side, which is 2 over 2 root 5. Once again, it's negative because cosine is negative in quadrant 3. Simplifying gives us -1 over root 5. If you choose to rationalize it, you would have root 5 over 5. Tangent is positive in this quadrant, so I just take the opposite side 4 over the adjacent side. Completing the division tells me the tangent ratio there is 2. Question 6, solve the equation cos theta equals root 3 over 2 for any angle between 0 and 360. So when I'm solving these, the first thing I want to do is determine which possible quadrants the terminal arm is in. So since cosine is positive, I know that it's either going to be in quadrant 1 or quadrant 4. So I'm going to have 2 solutions to this equation. There's a few ways you could do this. You could go to your calculator and use the inverse function. Make sure you're in degree mode. Type this in, and you're going to get a reference angle of 30 degrees. You can also do it using the special triangle, which I'll just redraw. I thought I had it there. Oops. There we go. So if I'm looking at this, I need to make sure that when I take the cosine, so I take the adjacent side divided by the hypotenuse. So I'm looking for an angle that has an adjacent side of root 3 and a hypotenuse of root 2. So that means 30 would be my reference angle. So that means this is 30 degrees and this is 30 degrees. So now I want to give the angle in standard position for each of those solutions. Well, the one in quadrant 1 is simple. It's just 30 degrees. The one in quadrant 4, sorry, I would take 360, subtract 30, and I'd get that angle in standard position to be 330. Okay, question 7 is very similar. So again, I'm going to first determine what quadrants I am in. Since sine is negative, I could be in quadrants 3 or quadrants 4. Notice for this question, they only want solutions between 0 degrees and 270. So I don't need to worry about the solution in quadrant 4 for this question. So now I'm going to look at this. Again, you could use the inverse function on your calculator and type in 1 divided by root 2, and you would get a reference angle of 45 degrees. You could also go to the special triangle. So where do I have an opposite side of 1 and a hypotenuse of root 2 would have a reference angle of 45. So what is this angle in standard position? Well, it's 180 plus 45 more degrees. So your solution here would be 225 degrees. Question 9, I feel like I missed a question. Question 8, determine the exact value of the side missing in the diagram below. So you really don't need special triangles for this. I think I erased that on your copy. This is just a case of Pythagorean theorem. So we can go 24 squared minus 12 squared. This gives us 432. So I then need to square root 432. I am going to simplify this radical. 432 is 144 times 3. So this is 12 root 3. Question 9, given that sine A is 5 over 12 and angle A is located in the second quadrant, determine exact values for the other two primary trigonometric ratios. Okay, so it says we're in the second quadrant, so we're going to come here. Again, we need to draw a triangle. Tells us the sine is 5 over 12. So our reference angle is always right here next to the x-axis. So if we have a 5 over 12, that tells us the opposite side is 5, and the hypotenuse is 12. Then using Pythagorean theorem, we get that this adjacent side has to be 119. So now we can find the cosine ratio here. It's the adjacent side, which is square root 119, which can't be simplified, over the hypotenuse, which is 12. Only sine is positive in this quadrant, so we need to make that negative. The tangent of that angle, we take the opposite side, which is 5, over the adjacent side, and we also need to make it negative because only sine is positive there. If we want to rationalize this here, we would end up with this. Last one, question 10. The coordinate of a point P on the terminal arm of an angle are shown. What are the exact trigonometric ratios for sine theta, cos theta, and tan theta? So again, we need to make a triangle here. Since we have a y value of 6, this side here is 6, and x value of 8 means this side is 8. Using Pythagorean theorem, we would find that the hypotenuse is 10. Since we are in the second quadrant, sine is going to be positive. So I'm just going to use my reference angle here. Opposite over hypotenuse is 6 over 10. Of course, we want to simplify that fraction to 3 over 5. The cosine of the angle is the adjacent side over the hypotenuse. Cosine is negative in quadrant 2. Simplifying the fraction gives us negative 4/5. Tangent is negative in quadrant 2. We take the opposite side divided by the adjacent side. And this simplifies to negative 3 over 4. So this is a pretty quick review. It is all stuff that's very important to this unit. If you have questions, make sure you come find me either in PLT or at lunchtime so that you're ready to expand this to the grade 12 trig unit.